All right, everybody. So absolute value inequalities today. So this is still 2-1. We just didn't get to quick finish yesterday. So let's do that right now. Okay, so this is 2-1 continued, and we are focusing on absolute value inequalities today. Continued. I just got lazy and didn't want to write the whole word. All right, I'm going to start off with I think I'll start with an example. So this one happens to be from it's one of the questions on last night's homework sheet. Not one of the ones that you did, but so if I end up assigning stuff from that sheet, this is number 27, so you don't have to do it all over again. All right, so here is the problem. 2 plus absolute value of 8x minus 9 is less than or equal to 3. So for the most part, our steps are going to be the same, sort of, but there's some tweaks we need to make because these are inequalities and not equations. So my first step is to still get the absolute value alone. But already you got to be careful because if that requires me multiplying or dividing both sides by a negative number, I'm going to flip that symbol over, right? In this example, that's not going to happen because all I have to do is minus a 2. So that wouldn't require any changes. But I need to be on the lookout for this. So let me give you some steps as we go. So 1, still isolate the absolute value. And I'm just going to put a star to remind yourself. Flip symbol if multiplying or dividing by a negative. So that's always whenever you're dealing with inequalities. So that's nothing new. It's just important to remember. Okay, so I do have to do this because my absolute value is not by itself. I'm going to have to minus the 2 to the other side. Okay, not so bad. Minus 2, minus 2. 8x minus 9 less than or equal to 1. So this next step, similar to what we did yesterday, I do still need to rewrite this twice, but when I rewrite it the second time, things get doubly weird. So watch what I'm going to do, and then we'll put it into words. I'm going to rewrite it twice. First time is, again, just going to be like I see it. I just don't write the absolute value bars. So first, I'm going to have 8x minus 9 less than or equal to 1, just like I see it. But then the next time, oh my gosh, you ready? You got to do 2 things. I'm going to write it like I see it, no bars, but I need to do 2 things. I need to flip that symbol over and make this negative. So it's going to look like this. 8x minus 9, flip the symbol this way and take the opposite of that number. Why does this happen? Remember, because everything in negative land basically gets flipped, right? Just like when you're ordering numbers, it all flips the other way. Okay, so let's put that in words. So rewrite twice. Once as is, no bars. And then the second time, no bars, but flip inequality symbol. And you have to do both. Take opposite. Take the opposite of the other side. I'll give you a moment to get that down. But that's super important. Extra highlight. Now, just like yesterday, I'm going to solve each one of these separately. Okay, so that's my third step. So I'm just going to solve each one like I normally do. So this should be relatively normal. 10 divided by 8 divided by 8. So that's, what's that, 5/4? And then I do the same thing on the other side. And all your normal rules hold. So if I do end up multiplying and dividing by a negative again over here, I flip the symbol again. This time I didn't because I didn't have any of that happening. So now here's where things get weird again. So far, is everybody with me? Yeah, okay. Now it's up to me to decide if this answer is an and or an or. What? How am I supposed to know? Well, we're going to take a look. I got to ask myself, are there numbers that are greater than 1 that are also less than 5/4? Let's change 5/4 to a mixed number. That might help. Isn't that just 1 1/4? So same thing, x is less than or equal to 1 1/4. So could you have numbers that are greater than +1 and less than 1 1/4 at the same time? Yeah, right? Like 1 1/8 would be in between those two. There are numbers that are bigger than 1 and less than 1 1/4, right? If there are numbers that do both, that do satisfy both of these, your answer is an and inequality. If there's not, your answer would be an or. Kind of weird, right? So, but it's up to us to determine, and you can't just write these two answers on the line without an and or an or and hope for the best. You have to specify which is it. Okay, so step 3, you're going to determine if your answer is an and inequality or an or. And so to do that for the ands, you're just looking, are there numbers that exist that satisfy both? So if the answer to that question is a yes, it's and. If not, it's an or. I am going to add on to this that it is always important to check. And it also depends on, I think on your homework, it does ask you to graph them. So if graphing is involved, then graph it. If not, then you would be done. So let's go ahead and write this as an and inequality and graph it. So yes, you can just write the word and, but let's say you were taking a multiple choice or something and they didn't have it written like this. They had it where the two are combined. All you have to do to write the ones where it's combined, you take the smaller of the two numbers, which in this case is 1, and then your symbols just always go like this, and then the bigger number. That's how you write this and inequality as an answer. Smaller number, bigger number, and then those arrows always go that way. And so if I need to graph this thing, I'll just have 1, I'd have 1 1/4, solid on each, shade in between. Is that so bad? Hopefully not. Let's see real quick if I don't have the answers to these ones, so I just want to see if I might have them in here. I want to pick one that's going to end up being an or without just picking through random ones and think for the best. What has that? I might just have to pick another random one. Yeah, all right. Okay, let's do, oh, I don't know. How about something like, ooh, I'm gonna hold on to that one for a minute. Oh, this is a good one. Well, all right, I'll do one more that's like normal, and then we'll do a few cases of weird ones. Let's do this one. So this is number 26 on that sheet from last night, if you're following along. So this looks like this: -5 times the absolute value of 9m plus 1 is less than or equal to -40. All righty, so what should I do first? What does my very first step have to be? Exactly, I got to get the absolute value by itself. So in order to do that, I'm going to divide both sides by -5. Do I have to do anything special because I just divided by a negative?
Yeah,
you sure do. So already that symbol's getting flipped over and I get a positive 8 on this side. All right, step 1 is done. Step 2 now requires me to rewrite this twice. Once like I see it, and then the second time, remember we're gonna write it, but we're gonna flip the symbol again and take the opposite of the other side. So one of my inequalities should look like 9m plus 1 greater than or equal to 8, just like I see it. Just don't write the bars. And then the second time, be careful on this one, 9m plus 1, flip the symbol over and make that a negative. Now I'm going to solve each one separately. So on one side, I get m is greater than or equal to a positive 7/9. Did you get the same? Okay, and then over here. I want to make sure everybody is super clear on this. Am I supposed, oh, let me erase this so you don't see the answer. Am I supposed to flip the symbol over this time? Do I flip that symbol over here? No. That, yes, that number is negative, but I'm not dividing by a -9. I'm dividing by a +9. I only flip the symbol if this number is negative, not if the top one is. That doesn't matter. So I'm going to leave the symbol exactly as it is because I am not dividing by a negative. And I get a -1. Oh, good. This one worked out. I didn't know what the answer was going to be, but I'm happy with it. So now I stop and I ask myself, are there numbers that are greater than 7/9, a positive 7/9? Are there numbers that are greater than that are also less than -1? Can you have a number that satisfies both of these that are greater than positive 7/9 and less than -1 at the same time? No. If you're ever not sure, right, you can always draw the graphs of them and look. Are there any spots where they overlap? No. These are going to be going in completely opposite directions. That means that this is an OR. Okay, so we're going to have an OR here. And for ORs, you cannot write them as a combined, like literally that's your answer. Just, I'm going to put the word OR a little bit higher. So ORs are a little bit easier to kind of wrap your mind around because you don't have to rewrite them as one thing. You don't have to with the ands, but if you're taking, you know, SATs or MCAS or most multiple choice is going to put it as that combined inequality. So it's important to be able to know how to write them. So any Hoosers, there's that. Let's do a quick graph of this, and we should be checking these. So let's see. If I'm going to graph this thing, the ORs are usually easier because they just go in opposite directions most of the time. So -1, I just want to be less than or equal to -1 or greater than or equal to 7/9. They're both closed. They go this way. So another reason how I know that that's an OR, there is no overlap of these two. Let's check some answers. So according to this, any number that's less than -1 is going to work. So if I go back up to my original and I just plug in a number like -2. So let's see, 9 times -2 is -18 plus 1 is -17. Absolute value of -17 is 17. 17 times a -5 is -85. Is -85 less than or equal to -40? Yeah, right? Because the negative land, the bigger the number is, the smaller it actually is. So this branch definitely works. Over here, 7/9. Let's pick something bigger than 7/9. How about 1? Right? So if we plug in 1, that should be easy enough. So that'd be 9 plus 1 is 10. Absolute value of 10 is 10 times the -5 is -50, less than or equal to -40. Yep. And if you want to get real fancy, you could check a number that should not work, like 0, right? 0, I do not have a bar over, so 0 should not work. So if I pop that in real fast, I get 1. Absolute value of 1 is 1 times -5. Is -5 less than -40? No, and it's not supposed to be, right? It wasn't supposed to work and it doesn't work. So, yes, bless you. Okay, let's try a real interesting scenario. Ready? Something like, I think I'll do number, this will be, I'll do number 19 from your paper here. Yeah. How do you know? Yeah, so, well, I'll show you
Wait,
what it looks like.
yeah.
Well, it's a little tricky. So there is, let me show you what it looks like. And write it down so we memorialize it for the video for our internet listeners. If you're listening and you are somewhere on the internet and you're not one of my students, will you just comment like where you're from? I'm just so curious. I'm curious if anybody's ever going to listen to this. Could you imagine if like aliens came and like my video was the one thing that they hear? Wouldn't that be wild? Hello, aliens. Anyway. My son is obsessed with space right now, so I've been learning so much weird stuff about. We were watching a video yesterday about the likelihood of an asteroid hitting.
Is it likely?
Yeah.
So one big enough to like wipe out the planet? No. It's what?
Jupiter protects us from any asteroids because of its gravitational force.
Oh, I didn't know that.
It
Wait,
actually
how's your
allows
son?
it to deflect it away.
Oh. That's very good. 5. So that one was, the guy was, he's like a astrophysicist of some sort or whatever, but he said that they can see all the ones that are big enough, they can see enough of them, and they're like, there's none that are close enough. But there's the one, so ones that are gonna wipe out the planet, not, no, we don't have to worry about those.
The sun's just eventually gonna die after all that.
True,
That's all.
true. The Earth is actually, before the sun dies, the Earth is gonna get super hot. And so, yes, but I mean, we're talking billions of years.
Oh, yeah, we'll be dead. We'll be gone.
But it is weird to think about, like, there's going to be, if we don't get off this planet at some point, there's going to be an end to humanity.
Every single one of them is gonna die.
So weird to think about. Anyway, yeah, so,
Well, I'm just gonna.
sorry, internet people.
But that's really weird to think about.
It is, it's so, it's weird.
Uh-huh.
All right.
Yeah, but one that doesn't.
So where were we? Oh, yeah. So Sam had said that this already is impossible. And she's right. Because think about it. When I take the absolute value, no matter what I plug in here, if I take the absolute value of something, it's always either going to come out to be 0 or some positive number. The smallest thing I could get out is 0. I'll never get a number that's less than or equal to -21. It's impossible. One thing I want to caution you on, though, you got to make sure that your absolute value is alone before you make that determination. Because if you look at something like number, I'm just going to see if there is one on here real quick. Yeah. Oh, 26. We just did it. Right? So if you look at 26, at first glance, you're like, oh, I'll never get a number that's less than a negative. Oh, but you got to divide both sides by a -5. So when you isolate the absolute value, then you got to step back and take stock and say, will I ever get a number that's less than this? No. So you could go through the motions and get answers, but if you go back and check it, they're not going to work because there is no answer to this. You will never get a number that's less than or equal to a -21. Yeah.
Is there ever be a situation where like the inequality sign is facing the other way?
Yes. Good question. So let me see if there's any on here. So this one, let's just write. This one has no solution. There will never be an absolute value. I'm going to add that's isolated, because that's an important thing. You can't just go around without isolating the absolute value. That will be less, I'll just say will be negative, because that's impossible. You can't have a negative. Okay, so let's just pretend. Do I see one question like this real quick? Yeah, actually, number 25 is going to be interesting. So if I do 25 real quick, you've got -10 absolute value, 9v minus 9 less than or equal to 90. Okay, so this does not have its absolute value isolated yet. So we need to start off by doing that. So let's go ahead and divide both sides by a -10. What happens when you divide by a negative?
Negatives.
You got to flip that symbol over and look what happens here. 9b minus 9 is now greater than or equal to a -9. Okay, so now this is the question that Matt was asking. What do we do here, right? You already know the answer. It's actually the opposite.
All real.
You can plug in whatever you want.
Because that has to be greater than.
Yes, this time I want greater than or equal to a negative number. I'm guaranteed a number that's greater than or equal, well, greater than a negative number, right? It has to be. Because I'm going to take the absolute value. So even if the absolute value comes out as 0, it still is automatically greater than this negative number. So I don't even need to keep going. You can, you're going to get 2 answers, but if you stop and think about them and check them, hopefully you realize, oh yeah, that should be all real numbers. I can plug in whatever I want. But so it's helpful to isolate your variable and then ask yourself before you keep going. Do I already know the answer here? You might. So answer, all real numbers. You will always have an absolute value greater than a negative. Isn't that something? So those are sort of the rare cases. Most of the time you just get a normal answer. But that's pretty much it. Do you want to do one more together or should I just let you do your homework? Okay, so what should we do? What should we do?
I'm not deciding. Anyone else can speak up. Would you like to do one more? Would you like to do your homework?
We did 27, 19, 25.
Alright, guys. Okay.
How about we just do the evens on the back? That's not so bad. So 18 to 30 on the back. You guys know what I'm talking about? Does anybody need this sheet? Oh. Yes, evens on the back, 19 to 30, or 18 to 30. Yeah.
Oh, the evens on the back.